Welcome. So we're going to go over the pumpkin patch problem. First, the standard that we are covering in this problem is for kindergarten. It focuses on operations and algebraic thinking. So the pumpkin problem. To the left, you can see the cute little picture of each little light up pumpkin. So the problem is Jack, Emma, and Mark leave a Halloween party and collect a total of 9 light up pumpkins. How many pumpkins can each friend have if all 3 friends each want the same number of pumpkins? So the concrete part of how we are going to solve this problem is the little pumpkins right here. So manipulatives are really important, especially with learning, because it can help connect the words on the page and the problem into how we want to process the information. So with that being said, the pumpkin that you see in the picture is each going to be on your desk and you can hold it in your hand, and there are 9 of them so that you can really lay it out and see how you want to group the pumpkins for the 3 friends in the problem. Now, representational is the next part because we're going to go over how we connect concrete, representational, abstract thinking so that it can help make this problem easier to understand. So I would like you to model for me how you would work the pumpkins so that each of the friends can have an equal amount. While you are drawing your picture, I'm going to draw a picture as well using this link right here. Okay, so I clicked the circle because I wanted it to be pumpkin shaped. And I made it orange for Halloween. 2, 3, 4, 5, 6, 7, 9. So this is how I chose to model my thinking. You can, of course, do it differently, but it's just an example of a website you can use to include some technology into the classroom on how you can draw. You can also feel free to get a pencil, pen, or paper and just draw out your thinking like that too and make the little circles, or you can do like the letter P if you want, PP, and then like keep putting that 9 times, however you best want to do it to demonstrate your thinking. Now we can go back here. Okay, now the third part, because I told you we're going to start off with just having these models. So first we did the concrete, which is helpful because you can hold it in your hand and feel it to connect to visually seeing it and then placing it down either using technology or paper. Now we're going to now put it with the abstract part. I want you to use numbers now to break down the thinking. So first you can get a sheet of paper or you can type on the computer and show me your logic only using numbers. You can pause this if you would like. Okay, here's how I did it. I know we have 3 friends. I know we have a total of 9 of these pumpkins. Now you can do 1 plus 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 1. And then if you could tell I got orange and I circled it in groups of 3 because I noticed that you could also say it is 3 plus 3 plus 3 because that also gives you 9. So can you see there's different ways that you could model your thinking, both with models, with how you draw it, with how you can place them around on your desk physically to see it. All of these 3 different ways tie together to getting your answer. So now you can get a piece of paper. You can also raise your hand and let me know how would you get the pumpkins and make it so that the 3 friends each get the equal amount of pumpkins. Here's the answer. Jack, Emma, and Mark can each have 3 light up pumpkins because of what we found previously. Either lining these up on our desk, you could see you could put it in like 3, and then you can have this like here, here, and here to have it be 3, 6, 9. You could have also come to the conclusion that they each got 3 from the picture. You could have had the 3 circles in groups, or you could have figured it out when you did the 1 plus 1 plus 1 plus 1 plus 1 plus 1, that kind of thing, or when you did it in just 3 plus 3 plus 3. So, thank you. You did a great job today, and that is how you solve the pumpkin problem.